Hi there, everyone. Today I'm going to read a report I put together just recently. Um, it was a chat with ChatGPT 4O, and I was asking it the question about what causes spin or vortex of a subatomic particle. So here's the report that I'm going to read from. Okay. What causes spin or vortex of a subatomic particle? Third edit. Brendan Darragh, that's me, and from the Vortical, the Model G Vortical Motion Group. So here I've just given a figure which I got off the internet. Figure one, to differentiate each of these subatomic particles, we use plus and minus as their identity, considering their direction of spin. So the question I gave to ChatGPT 4O was, what causes spin or vortex of a subatomic particle in terms of subquantum kinetics and conventional physics? GPT said the spin or vortex-like behavior of subatomic particles is interpreted differently in subquantum kinetics and conventional physics. Let's break down both these perspectives. One, conventional physics, quantum mechanics, and quantum field theory. In conventional physics, spin is an intrinsic property of fundamental particles, much like mass or charge. However, it is not literal rotation motion. Sorry, I'll read that again. However, it is not literal rotation motion in space, but rather a fundamental quantum number associated with the particle's wave function. Quantum mechanical view. Spin arises from the symmetry properties of the quantum field that describes the particle. It is related to the representations of the Poincare group, which governs space-time symmetries. The wave function of an electron, for example, is a spinor which transforms in a unique way under rotations, leading to phenomena like the spin half nature of fermions. Here's a diagram I just got off the internet. Figure 2 is heuristic depiction of spin angular momentum cones for a spin half particle. You can see the S is the direction of spin, and these are discrete quantum states of pi of h bar over 2. So also part of this quantum mechanical view, the last bit is measured values of spin are quantized in units of h bar over 2. That's Planck's constant h bar over 2. Quantum electrodynamics, QED, and quantum field theory, QFT. In quantum field theory, spin is linked to the field equations describing particles. Fermions, like electrons, obey the Dirac equation, which incorporates spin naturally through relativistic considerations. Spin also determines how particles obey the Pauli exclusion principle, fermions, or can coalesce into collective states for bosons. Spin and vortex-like phenomena. In condensed matter physics, spin vortices can emerge in certain materials, e.g. spinor Bose-Einstein condensates. The spin of a particle also interacts with electromagnetic fields, leading to effects like spin precession and the Zeeman effect. Here's another diagram I got off the internet. Figure 3, spin and orbital magnetic moment. When we talk about the magnetic moment of a system, then it means we are talking about their net magnetic moment. Fundamentally, the contributions to any system's magnetic moment come from two different sources, i.e., one, motion of an electric charge, that is electric current, and second is intrinsic magnetism of elementary particles, such as an electron. So the spin is coming from, in this atom here, is coming from the orbital magnetic moment of the electron spinning around the nucleus, and also the intrinsic angular momentum or spin magnetic moment of the electron, which in quantum mechanics is an abstract, it's not the same as rotation, is an abstract property. It's an abstract property that was given by a spin quantum number. So it's not the same as actual rotation, it's some abstract property. But in subquantum kinetics, it's the vortex of the etheron fields, etheron fluxes. Here's another figure. Figure 4, spin of an electron as a magnetic dipole moment, shown in terms of magnetic north and south poles. So number 2, subquantum kinetics, SQK. Here's another figure I got from Paul Lavillette's book. Figure 5, structure of a positive and negative etheric subatomic particle as intuited in 1895 by Besant and Leadbeater. Just as a moving charge would generate cold components in its virtual electric force field, so too through its vortical diffusive flux, a subatomic particle would generate cold components that would cause its surrounding electric potential Turing wave pattern to develop magnetic effects, even when the particle was not in motion relative to its ether ambient. This may be what causes a subatomic particle to have the property of spin, i.e., ether vortex current. This property was first discovered in 1922 in an experiment carried out by Stern and Gerlach. In subquantum kinetics, spin and vortex-like motion arise from subquantum processes involving an open, nonlinear reaction-diffusion system that generates structuring at microscopic levels. Spin as a self-organizing wave pattern. SQK proposes that particles are dynamic structures within an ether-like medium governed by reaction-diffusion kinetics. These structures arise from subquantum fluxes of etheric energy which create a stable standing wave. The vortex nature of spin results from a rotational, self-organizing pattern in this medium. Vortex formation from ether flow. Particles in SQK or subquantum kinetics are theorized to behave like solitons or localized vortex structures in a self-sustaining wave medium. The energy exchange between subquantum ether fluctuations and the emergent particle stabilizes. Sorry, I'll read that again. Energy exchange between subquantum ether fluctuations and the emergent particle stabilizes its intrinsic angular momentum, giving rise, I'll read that one more time. Energy exchange between subquantum ether fluctuations and the emergent particle stabilizes its intrinsic angular momentum, giving rise to what is perceived as spin. Spin and zero-point energy interaction. Vortex motion could be maintained by continuous influx and outflux of zero-point energy. In this model, spin is not just a mathematical property, but has real physical underpinning in subquantum flow dynamics. Connection to mass and charge. SQK suggests that spin, charge, and mass are all interrelated, emergent properties of a self-organizing etheric flux. The direction and strength of the vortex influence charge polarity, and mass may emerge from the degree of structuring within this vortex field. Okay, comparing the two perspectives. So, nature of spin in conventional physics, this is intrinsic quantum property, not literal rotation. In subquantum kinetics, it's a vortex-like self-organizing ether flow. Mathematical representation. In conventional physics, it's spinor transformations, quantum field operators. In subquantum kinetics, it's reaction diffusion equations, soliton dynamics. Cause of spin. In conventional physics, it's fundamental space-time symmetries, Vortical group. In subquantum kinetics, it's self-sustaining energy flux in ether-like medium. Spin interactions. In conventional physics, it's coupling to magnetic fields, relativistic effects. In subquantum kinetics, it's interaction with subquantum energy flows. Okay, conclusion. In conventional physics, spin is a fundamental but abstract property described mathematically through quantum field theory. In subquantum kinetics, spin emerges from vortex-like energy structures in an underlying etheric medium. If SQK is correct, spin would have a deeper physical cause rooted in subquantum energy flows rather than being merely an abstract quantum number. So ChatGPT asked me, would you like to explore how these ideas could be experimentally tested or connected to other areas of physics, like the holographic principle? And that's me, the author said, vortexes occur when faster moving particles in a fluid meet slower moving particles in a fluid. Subquantum kinetics, that can mean that some of the reaction equations happen faster than others, or diffusion for some etherons happens faster or slower. Can you describe this further in terms of vortex spin in subquantum kinetics? For example, using water going down a drain. I use it to explain causal spin vortex in subquantum kinetics. ChatGPT said, great analogy. Let's break this down using the water drain vortex as a way to understand spin in subquantum kinetics. Number one, water drain analogy and subquantum kinetics. When water drains, a vortex forms due to differences in velocity between fluid levels, pressure imbalances driving rotational motion, conservation of angular momentum as fluid is drawn inward. Now apply this to subquantum kinetics reaction diffusion ether model. Faster versus slower etheron flows. Some etherons, subquantum entities, diffuse far faster than others due to reaction kinetics in the ether medium. Density gradients and imbalances. Differences in reaction rates cause regions of high and low etheron concentration, leading to circulation-like flows. Vortex stability and self-organization. A self-reinforcing cycle emerges. Faster etheron flows create feedback loops that maintain a stable spin structure. Number 2, spin as a vortex in ether flow. In SQK or subquantum kinetics, a particle, like an electron, isn't a solid object, but a wave-like energy node in an ongoing subquantum flux. Etherons flow into the particle's center, like water into a drain, creating a stable rotating pattern. The faster inward flux compresses and speeds up near the core, analogous to a tornado intensifying. The vortex remains self-sustaining because the reactions driving it continually replenish and balance the flow. Number 3, why is spin quantized? Just like how fluid vortices, so I'll read that again. Just like how fluid vortices stabilize at specific angular momenta, like hurricanes forming at preferred sizes, subquantum vortices settle into discrete spin states. The quantization of spin in quantum mechanics, e.g., h bar over 2, Planck's constant over 2, for electrons, correspond to natural stable modes of subquantum ether flow. 4, role of diffusion versus reaction rates. If diffusion is too fast, the vortex dissipates. If reaction rates are too slow, the vortex doesn't sustain. Only specific parameter balances allow stable, long-lived vortices, explaining why fundamental particles have fixed spins. GPT asked, would you like a deeper dive into the math behind this or an illustration? The author, who's me, said, yes, go deeper into the math, please. ChatGPT said, to mathematically describe spin as a vortex subquantum kinetics, let's break it down into fundamental components using reaction diffusion equations and fluid dynamics analogies. Subquantum kinetics. So, number 1, reaction diffusion equations in SQK. Subquantum kinetics suggests that particles emerge as self-organizing wave structures in an underlying medium of etherons. The governing equations take the form of nonlinear reaction diffusion equations, similar to those found in chemical oscillations and fluid systems. A general reaction diffusion equation for etheron species, psi, in subquantum kinetics is partial differential of d by phi, d psi over dt equals d nabla squared psi plus r psi, where d is the diffusion coefficient, can vary per etheron type. Nabla squared psi represents the spatial diffusion Laplacian term. R psi is the nonlinear reaction term that governs self-organization. For vortex formation, we need differential reaction rates between different etherons, meaning that some subquantum processes propagate faster than others. In fluid, number 2, vortex formation from diffusion gradients. In fluid dynamics, vortex motion arises due to shear flow. In subquantum kinetics, an analogous situation occurs when etheron fluxes move at different rates, leading to rotational instabilities. Using a polar coordinate system of r theta, we express the electron flow velocity as v r theta. So partial differential of d v theta over dr does not equal 0. This means there is a shear gradient in the ether flow, which causes rotational motion, just like in fluid vortices. Simple model for vortex motion in ether diffusion is partial differential of d omega over dt plus the scalar product with nabla omega equals nu nabla squared omega plus s, where omega equals nabla times v is the vorticity of the ether flow. V is the velocity of the ether flux. Nu is the subquantum viscosity term. S is a source term from reaction kinetics. For a stable spin state, this equation must lead to self-sustaining vorticity, meaning the reaction source term S continuously replenishes the vortex. Number 3, stability of spin, quantization from eigenmodes. In quantum mechanics, spin is quantized in discrete units. In SQK, this quantization emerges from standing vortex modes in the subquantum medium. We analyze this by solving for stable eigenmodes of the vortex system using a wave-like equation, such as nabla squared psi plus k squared psi equals 0, where k is a wave number that determines the discrete allowed vortex states. For a circular vortex solution, the stable modes are Bessel functions. Psi r theta equals jm ar exponential e to the power of im theta, where m is an integer representing the quantized spin state. This shows that spin emerges as a quantized vortex mode in subquantum ether flow. Number 4, conservation of angular momentum in subquantum vortices. In classical physics, angular momentum L is given by L equals R times P, cross product. L equals R cross product P. For a vortex in SQK, angular momentum conservation ensures stability. Scale of it, et equals 0. Since the vortex is self-sustaining, the subquantum flux dramatically maintains a constant intrinsic angular momentum, leading to an effective h bar over 2 spin quantization. Key takeaways. 1. Spin in SQK is a stable vortex formed by reaction diffusion imbalances. 2. Quantization emerges naturally from standing wave solutions, M-mode eigenfunctions. 3. Self-sustaining angular momentum ensures stability, mimicking quantum mechanical spin states. Would you like me to illustrate this with a diagram or go deeper into any part? The author said, yes, with a diagram, thank you. ChatGPT said, I'll generate a diagram illustrating how spin emerges as a vortex in subquantum kinetics, showing strong diffusion gradients causing shear flow, formation of a stable vortex due to reaction diffusion dynamics, quantization of spin, via standing wave patterns. Plot in figure 6 was generated by ChatGPT. So here's figure 6. Figure 6 is a visualization of spin as a vortex in subquantum kinetics. So this is the image that the plot that the ChatGPT is given with y subquantum space and x subquantum space, spin as a subquantum vortex, and the z-axis is ethron density. So it's just some kind of plot or picture it's produced to express what it's trying to say in terms of vortices, spin vortices and subquantum kinetics. So in figure 6, the blue arrows represent the rotational motion of etherons due to reaction diffusion imbalances. Background color shows ethron density forming a stable core structure. Vortex pattern mimics the intrinsic angular momentum seen in quantum spin. It illustrates how differential diffusion rates create a self-sustaining vortex, naturally quantizing spin. Would you like additional refinements or explanations? Author said, yes, thank you. ChatGPT said, you're very welcome. I'm glad you found it helpful. Would you like to explore further refinements, such as breaking down reaction kinetics in more detail, how diffusion rates drive vortex formation, relating this model more explicitly to quantum mechanics, e.g. deriving spin quantization from vortex stability, extending this to larger structures, e.g. connections to cosmic scale vortices or consciousness fields. Let me know which direction excites you most. Author said, yes, can you look at breaking down reaction kinetics in more detail, how diffusion rates drive vortex formation? ChatGPT said, great, let's break down the reaction kinetics in subquantum kinetics and explain how differential diffusion rates drive vortex formation. Number 1, reaction diffusion system in subquantum kinetics. Subquantum kinetics proposes that etherons follow reaction diffusion equations, similar to those seen in chemical systems and fluid dynamics. A basic two-component reaction diffusion system follows partial differential of psi1 d psi1 over dt equals d1 nabla squared psi1 plus r1 psi1 psi2, and then partial differential of d psi2 over dt equals d2 nabla squared psi2 plus psi plus r2 psi1 psi2, where psi1 and psi2 equal concentrations of two ethron species. E1, E2 equals diffusion rates for each ethron. Sorry, each ethron type, that should be. Nabla squared equals Laplacian spatial diffusion term. R1, R2 equal nonlinear reaction terms. Key idea, unequal diffusion drives vortex formation. So unequal diffusion drives vortex formation. If D1 is not equal to D2, one ethron diffuses faster, one ethron type diffuses faster, or substrate. It creates spatial gradients. These gradients flow imbalances. These gradients create flow imbalances, generating rotational motion. Feedback loops from reaction terms reinforce the vortex. Number 2, role of reaction kinetics. Reaction terms R1 and R2 define how electrons interact. A self-sustaining vortex needs autocatalysis, self-reinforcing growth of one species, nonlinear saturation to prevent runaway expansion, diffusion imbalance, so rotational structures form. A simple activator inhibitor model, like in chemical oscillations, is R1 equals A psi1 minus B psi1 psi2, R2 equals C psi2 plus D psi1 squared minus E psi2, where A and C are growth rates. E, D, and E control interactions and suppression effects. These terms create oscillatory self-organizing behavior similar to Berzov-Zhabotinsky reactions, which naturally form spiral waves, analogous to quantum spin. Number 3, formation of a subquantum vortex. Now let's analyze vortex formation. Number 1, electron species fuse at different rates. D1 is greater than D2. 2, spatial gradients cause localized flow instabilities. Number 3, a circulating feedback loop emerges, leading to a stable spin vortex. Mathematically, this results in a rotating wave solution of the form psi1 r theta t equals a e to the power of I in brackets m theta minus omega t close brackets j to the m kr, where a is amplitude, jam j to the m kr is Bessel function governing radial vortex structure, e to the power of I in brackets m theta minus omega t describes angular and temporal rotation. The solution quantizes spin as only discrete. This solution quantizes spin as only discrete values of m correspond to stable vortices. For physical interpretation, faster diffusing electrons pull inward, creating circulation. Reactions reinforce the vortex, stabilizing spin. Only specific vortex modes persist, mirroring quantum spin quantization. Summary: unequal diffusion rates create flow gradients, induce rotation. Reaction kinetics sustain the vortex, prevent dissipation. Quantized modes emerge, linking spin to quantum mechanics. Would you like a refined simulation or equation derivation? Author said, can you elaborate more on relating this model more explicitly to quantum mechanics, e.g. deriving spin quantization from vortex stability? ChatGPT said, absolutely. Let's go deeper into how spin quantization in quantum mechanics can emerge from vortex stability in subquantum kinetics. One, quantum spin, key properties. In standard quantum mechanics, spin is intrinsic, not classical rotation. It is quantized, e.g. electrons have spin plus or minus h bar over 2. It follows SU2 symmetry, meaning it behaves as a complex valued spinor rather than a classical vector. For spin to emerge from a subquantum vortex model, we need stable, self-sustaining rotation in the subquantum medium, discrete eigenstates, like standing waves in quantum mechanics, SU2-like transformations, meaning spin behaves like a fundamental angular momentum system. Number 2, vortex, stability, and discrete eigenmodes. Step 1, energy minimization and stable spin states. A vortex forms due to reaction diffusion imbalances. Stability conditions require that energy does not leak away. Only certain vortex modes remain stable, leading to quantized angular momentum. Fluid dynamics, a stable vortex solution follows this equation here, partial differential of d omega over dt plus, in brackets, v scalar product with nabla, close brackets, omega equals nu nabla squared omega plus s, where omega is vorticity, i.e. nabla cross product with v, velocity. Nu is viscosity, damping term. S is a source term, maintaining rotation. Stability, the vortex must self-organize to sustain itself. Only certain circulation states survive, i.e. quantization. Step 2, quantization from eigenmodes. In quantum mechanics, spinor wave functions satisfy the Pauli equation. S hat psi equals small s psi, where s small s is equal to plus or minus h bar over 2 for electrons. For a vortex in SQK, an equivalent equation arises from the standing wave conditions in the subquantum medium. We have nabla squared psi plus k squared psi equals I think psi is the subquantum potential. Concentration, I think that's what it is. The allowed solutions are Bessel functions. Psi m are theta equals jm kr e to the power of I m theta, where m is the quantized vortex mode. This naturally leads to discrete angular momentum states, much like quantum spin eigenvalues. Number 3, SU2 symmetry from vortex rotations. In quantum mechanics, spinors transform under the SU2 group. SU2 transformations describe rotations in an abstract 2D complex space. SQK, the vortex solutions from a Hilbert space of standing waves. These wave solutions obey SU2-like transformation rules under small perturbations. Phase shifts in vortex flow mimic spinor rotations. Spin emerges naturally from symmetry constraints on subquantum vortices. Number 4, mapping SQK vortex states to quantum spin. 1. Vortex core structure goes to direct field behavior. Core behaves like a localized energy mode, similar to electron wave functions. 2. Spin precession equals vortex perturbations. In QM and quantum mechanics, spin precession follows Lama's equation. In SQK, subquantum kinetics, perturbed ether flow leads to similar precessional effects. 3. Spin quantization equals vortex eigenstate. Only discrete vortex states are stable. The lowest mode corresponds to h bar over 2, matching quantum mechanic predictions. Conclusion. Stable vortex solutions explain why spin is quantized. SU2-like symmetries arise naturally from subquantum wave dynamics. Spin precession is linked to vortex perturbations in the subquantum medium. Would you like a diagram or a deeper derivation of SU2 symmetry on vortex dynamics? Author said, yes, thanks. ChatGPT said, you're welcome. I'll generate a diagram illustrating how vortex stability leads to spin quantization and how SU2 symmetry emerges from vortex transformations. This will visually connect subquantum vortex model to quantum spin. So in figure 7, that's this figure here, this spin quantization from vortex stability and the vortex energy density. Figure 7, here's a visualization of spin quantization from vortex stability in subquantum kinetics. So that's what figure 7 is talking about. So in figure 7 that I've just shown you, color map represents the vortex energy density, showing stable quantized mode. Arrows illustrate the rotational flow of electrons, forming a self-sustaining vortex. The standing wave pattern is similar to Bessel functions, matching quantum spin eigenstates. Now, I don't fully understand this plot, but that's the way ChatGPT gave it to me. So there may be something more going on here that I can see. This supports the idea that spin emerges from stable vortex eigenmodes in subquantum space, just like in quantum mechanics. Would you like to dive deeper into SU2 symmetry, derivation, or anything else? So I've just said maybe another time. Okay, so that's that. That's the end of the session. The talk on what causes spin or vortex in a subatomic particle with the help of ChatGPT. Okay, well, thank you very much, everyone, for listening. I hope you have a wonderful day. Cheers. Thank you.